Okay, so we've got 7.4 division properties of exponents. So let's do a review real quick of negative exponents and zero exponents. So hopefully you remember from last time, this cube is going to apply to all factors in parentheses. So this would be 2 cubed, 8, b to the negative 9th, but we can't have negative exponents, so it's 8 over b to the 9th. Okay, second one, that's 2 to the negative 4th, which would cause 2 to the 4th to go into the denominator, into the negative 3rd to the negative 4th, power to a power multiply, that would be m to the 12th. So that stays in the numerator since it's positive. Okay, and then of course anything to the 0th power 1. All right. So we're talking about division properties of exponents. So if you recall from the last lesson, whenever we multiplied with like bases, we added the exponents. So you can probably guess what's going to happen when we divide with like bases. Sure enough, you subtract the exponents. So keep the same base, subtract the exponents. So let's see an example here. So first one, we're going to keep the same base, subtract the exponents. 3 minus 7, negative 4. But of course, we can't leave negative exponents in the answer. So that's 1 over n to the 4th. The reason why this works, here's the derivation of the rule. N cubed is n times n times n. N to the 7th is n times n times n times n times n times n times n. Of course, you don't want to do this every time. This is just the derivation of the rule. So we could cancel 1 here, 1 here, 1 here, 1 here, 1 here, 1 here. We're left with a 1 on top, not a 0, a 1. And down here we're left with n to the 4th. So that's why the rule works. So over here, we're going to keep the same base, subtract the exponents, n to the 4th, which makes sense. I've got 7 of them up here, 3 of them down here. If I canceled 3 of them here, I could cancel 3 of them from the top, leaving just 4 of them. So when you're dividing, subtract the exponents. Okay? So with this one, we're going to keep the same base, x, subtract the exponents. 15 minus negative 2, 17. This one, the negative 6, only applies to the x. So that's really 3 over x to the 6th. Okay? Here, we've got 1/2. Then we have x to the negative 2 over x to the 4th. So keep the same base, subtract the exponents. Negative 2 minus 4 would be negative 6. X to the negative 6th. But we know what's going to happen with the negative exponent. It's going to cause them to flip positions and end up in the denominator. So that's really 1 over 2, and then x to the 6th goes to the denominator because of the negative exponent. Okay, so let's simplify our coefficients and then our variables alphabetically. So let's make our fraction bar, because we know we'll have some stuff on top and probably some stuff on bottom too. So first, negative 6/4. That'll reduce to negative 3/2. Now for our r's. We have r cubed over r to the 4th. Well, there's 3 of them there, 4 of them down here. We'd get rid of those 3, and then we'd get rid of 3 of them here, leaving just the 1 down beneath here. Now we have k to the negative 2nd divided by k to the negative 6. So let's subtract our exponents. Negative 2 minus negative 6. Negative 2 plus 6, that would be k to the fourth. So, k to the fourth. Final answer. All right, let's have a look. So first thing I noticed about this one is I have a negative exponent. Okay, so there's several things you could do here. If it were me, I would go ahead and flip my base and then change my exponent to positive. So let's flip it, get our reciprocal. So that becomes 3f to the fourth on top. Negative 2a to the negative third in the denominator. And since we flipped it, we're going to change the negative 3 to a positive 3. So when you have a fraction, your exponent applies to both numerator and denominator. So we've got 3 cubed, 27. Then f to the fourth cubed, f to the 12th, using the rule we learned last time, power to a power multiply. Now we have negative 2 cubed, that'd be negative 8. Then we have a to the negative third cubed, power to a power multiply. So we're almost done. One little problem. We've got a negative exponent. So as we've been talking about, the negative exponent will cause the base to flip positions. So the a to the ninth will go to the top. So now we have 27, a to the ninth. F to the 12th stays. Negative 8 in the denominator. So, as we learned before, anything to the 0th power, 1. Okay, so let's review our rules. So to divide using scientific notation, okay, we're going to divide the numbers before the powers of 10. Then we're going to subtract the exponents. So for instance, we really have right here something times something over something times something, the product of two different variables. So we could group them. Okay, so we're going to group these, and we're going to group these. Okay. So first, 5.2 divided by 1.3. That'd give us 4. Then 10 to the 51st divided by 10 to the 20th. We've got the same base, and we're dividing. So keep the same base, subtract the exponents. And it's already in scientific, so no need to compensate. So divide your numbers, divide your powers of 10, subtract your exponents. So let's review multiplying. First, we'll do our coefficients, then our variables. So here we've got 4, negative 9, negative 1. That'd be 36. Then we have x cubed, x squared, x. That'd be x to the 3 plus 2 plus 1, 6. Minus 3 times 5, 15. X times x cubed, x to the fourth. Minus 8, x to the sixth. But I see one thing we can do. Collect like terms here. That would give us 28, x to the sixth, minus 15, x to the fourth. So always look at the end to see if you can collect any like terms. All right. This could be a good place to pause and work them on your own and check and see if we get the same thing. So let's divide our numbers. 2.4 divided by 9.6. That would be 1/4. to the 2 minus -5, 7. So that's really 0.25 times 10 to the 7th. Oh, not scientific notation. So 0.25 becomes 2.5. We just multiplied this guy by 10. Since we multiplied him by 10, we need to divide this guy by 10. One gets bigger, one gets smaller, as we talked about before with compensation. Last one. So 5 divided by 2.5, 2. 10 to the, oh, hold on there, Van Meter. We've got this cube that we have to apply to both before we do anything. So that's 5 cubed. That would be 125 times 10 to the 5th cubed, 10 to the 15th, power to a power multiply. Now down here, we've got 2.5 squared. That'd be 6.25 times 10 to the 14th squared, power to a power multiply. Now we can divide our numbers. So